Hello everyone. For this tutorial video, I would like to demonstrate how to analyze complicated curve shapes by breaking them down into the simpler curves, as well as breaking them down into polygons, i.e. straight line shapes. As you may already be well aware, most curves you see in artistic pieces or even in everyday objects are not the simple curves I described in the previous tutorials, but rather have a much more interesting but complex shape. However, if we stop to study these curves, we can prove that we can break them down into simpler curves as well as polygons. For example, a Valentine's Day heart, which you may also see used in card suites, is obviously not predictable by a simple circle, ellipse, or part of those two objects. But if you were to draw lines on the shape, you would see that you could break it down into a rhombus or rotated square and two semicircles. So we would find the area that way, i.e. the area of the square plus the area of the two semicircles, which equals an area of a full circle. To figure out the perimeter, we would perform a trick similar to figuring out the perimeter of complex polygons. Namely, we would add the perimeters of the individual shapes, but take away the lines that are inside the shape. So in this case, the perimeter of the square would only be two of its lengths rather than all four, and the perimeter of the semicircles would only be the curved shape, as the flat or straight end of the semicircle is inside the shape and therefore not part of the perimeter. Some shapes are made out of nothing but curves, no polygons, such as the more round or squishy heart you may also see as an interpretation of it. We can see, if we break it down, that it is two semicircles, but instead of a square being the remaining part, it is 2/4 of an ellipse instead. And so we add the areas as usual. And in this case, the perimeter is all the lines except for the intersecting lines we used to dissect the shape. So it would be the arc length of the two semicircles plus the arc length of the 2/4 ellipses. We can also use these types of techniques to analyze something such as a rounded rectangle, which is like a rectangle, except you can't use the rectangle formula directly owing to the curves of the corners. So we would measure the units that the length and width take up, and for every unit that is occupied by a curve instead of the regular rectangle shape, we should notice the curve is simply 1/4 of a circle. And because there are 4 of these curves with identical radiuses, we get a full circle in our area formula. So the area is area of the rectangle minus the 4 units occupied by the curves, but plus the full circle that these curves constitute. By the same exact reasoning, the perimeter would not be exactly a rectangle, but would instead be a rectangle minus the parts that are at the curves, plus the arc length of each curved corner. Although these types of techniques are very convenient and useful for most objects that are complex curves, they will not work for every object possible because many objects have blank or empty space inside them, such as a ring. Therefore, in our next tutorial video, we will study 2D shapes with empty space inside their areas, as well as ways to find their area and perimeter. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.